Alright, we're back. We covered privilege escalation last time via Windows. We skipped some exploration of Linux with a Python file and escalating through that. But this time, we're first going to start on some Kali Linux exploration where we will find the SSH key. Before I do that, I want to get ready for the second one by starting an nmap scan. And I learned some new stuff. If we use IPA, which is the same as IP address, we can see the CIDR notation for the network range. We're on the same network as these Windows machines. So I want to set up a scan of the network. So I should be able to do O for operating system to tell me which of the ports is detected as Windows 230, and then just indicate the network range there. I'm tempted to grep anything that says Windows to make it easier, but I'll go ahead and just run that in the background. Sudo. Alright, so that's going. And for our lateral movement through Linux, we need to make sure we're the root user. Kali should be root. Let's just check on how we confirm. How to check if I'm root user on Linux Kali. Who am I? If the output is root, you're currently logged in as root. ID. Root has user ID of 0 if we do ID command. So we'll do that. Let's get logged into the Windows side just for preparation purposes. GUID is 1001. Log name, output root, sudo who am I. Sudo who am I. Sudo who am I. Okay, that's what we want to see. Alright, so we are effectively root. And if we were in a Linux system target and we wanted to find the SSH key to start to try and move laterally through the system once we've escalated privileges, we'd want to check out the Kali user. So first we'll go to home, and this is listing users. We're going to jump to the Kali user. You're not going to see it here. You want to do LSA. We're going to drop a, well, we're root, but we'll drop a sudo anyway. And now you can see SSH right there. So let's go ahead and cat that. Just want to make sure we're in the proper directory here. Yep. So cat.ssh. I'm going to sudo it since it's a shadow file. .ssh is a directory. Oops. ls. Authorized keys. SSH. Clear this for some room. ls cat authorized keys. So there, I'm looking here. SSH RSA. SSH keys will tend to have an extension of .pem. You may find unknown hosts. This shows where the user may have used. And you'd use the following. SSHI, which Let's just copy that and learn about the command real quick. Let's see. Explain plus. I is identity of the file. Host is the host name or IP address of the server you want to connect to. So we could probably just connect to loopback 127.0.0.1. So we got the key. I wonder if we can just target that file. Let's take a look at the workshop, review the ID. So it actually wants us to, in this workshop, visit compromised user. So let's go ahead and cd ls cd back one more time. The dot dot moves you back up the file tree. Now we have cd compromised user, pressing tab to autofill it. Now we should have bash logout, bash cache, ssh. There we go. cd.ssh ls. So that's what we're looking for, is the rsa.pem. So we would do, let's go ahead and copy this. Copy, oops, copy. You can also do Control-Shift-C in your terminal. SSH I for identifier. Control-Shift-V. Certainly don't need that. We need the ID rsa.pem, and we'll cat that after this. And then the compromised user. So we'll try Kali. Actually, I guess it just wants us to do the compromised user at the loopback, since we're charting ourselves. And let's go ahead and let's see. Notice that we're allowed into SSH. Yes. Permission denied. Let's clear this up twice on the numpad to get the previous commands, and let's sudo this. It's probably a good warning to see. Let's read it. It is possible that someone's doing something nasty. Possible that the host key has changed. The fingerprint sent by this. Please contact your sysadmin. Add correct host key to get rid of this. Interesante. So we are on root. We have changed to this directory. Let's go ahead and actually review the ID rsa.pem. So this is an SSH key. These header and footer items here are important for it to be recognized as said SSH key. Review the file to use it to simulate a lateral move. SSH compromise user. Let's try it one more time. Without sudo. Review it one more time. Compromise user. Let's just run it and see. Permission denied, public key. Notice that you were allowed into the system knowing the password, not knowing the password for compromised user. So we are currently root. Sudo who am I? We are root. Let's try getting into our actual IP with this and see if that does anything different. permission denied, load key, permission denied. But if we run sudo, it also gives us an error. Let's see what this says. It's different at least. Okay, so it looks like that worked that time instead of using the loop back, which threw an error. Remote host identification changed. It is possible that someone's doing something nasty. Add the correct host key in known hosts. So I think what had happened was when we used not the loop back, but we could have done it right here if we would have read the rest. Adding known hosts here, but it automatically did it when we ran this, the authenticity of the host, blah, blah, blah. This was added here to known hosts. Once we got the key in, so now we have access via the SSH lateral movement strategy for Kali. So now we're effectively the compromised user. Let's see if they have root access. Nope. Alright, we don't know the password for that. That's okay. So we can do ID, and it is not 1001, it's 1002. Seems like pardon me, right here, compromised user. Let's do take a look at compromised user. Now let's look at Kali and see what the differences are. 1002, Kali Linux, home Kali. Let's see. Command to check permissions of users in Kali Linux. Coffee break. We want to look at the shadow file rather than get in password, I suppose. Shadow. Okay, so we have in the shadow file read-write privileges of the shadow file. Root is the owner of the file. Oh well, okay. So getting a little off track here, but we went ahead and got access to another user via privilege escalation, and then we moved laterally using that SSH key that we found for the compromised user in the home file, the home directory of Kali. So when you switch to just tilde, it switches to your user's home directory, but we can go back one, and this is what we got into. We got into the SSH shell with their RSA ID. So now we'll do the next step. We've been running an nmap here. Let's go ahead and scan through this quickly for Windows users. So I'm seeing Microsoft here on this IP. And let's see if we see any other ones that look similar to this. There's another one, a bunch of Microsoft stuff on this IP. And then this one's going to be the Linux IP here, which is us, I believe. So we found 3 with open ports. That must be Windows 1 and 2. Let's go ahead and sign in and just check to see which one this is. Work with me, buddy. Open, no. Set CTEC, yeah, okay, that works. We can do that one. Command prompt. In Windows, we're going to run ifconfig rather than ifconfig. This is 315189. Let's see if we have that here. There we go, 315189. Perfect. So, on the Windows 1 system, which is here, establish a interpreter session by using these items, using the payload reverse TCP. So let's go ahead and open up a new tab and get msfconsole running. I want to see the ASCII graphics, so I won't use -Q for quiet. That's gonna shut up the fun graphics at the beginning, but I like to see them. So we're going to establish a interpreter session by using username admin, password academy. It doesn't really indicate if we're going to use SMB, but that's what we've used in the past. Let's just try that first. So we'll do a search Windows x64. We'll just do search SMB because I don't know how to chain that together correctly. And we're looking for not an auxiliary, but an exploit. Windows x64 SMB is probably what I'm looking for. Exploit, generic. SMB psexec, I think is what we want. Psexec, I believe, is some sort of remote. What is psexec in Windows? Some sort of remote platform, remote systems access platform. Command line tool developed by sysinternals, now part of Microsoft, that allows you to execute processes on remote systems. So we're taking an innocent program and using it maliciously. Alright, so we're going to use 56 psexec. So we'll scroll down here, use 56, clear this out. Let's see what the options are. SMB pass. So we'll set SMB pass to administrator. Oh, that's wrong. Set SMB pass. That's the username. We want to have the password that we cracked with John the Ripper previously. Set SMB user to administrator. So now we can type options. You don't need to do show options, just options. So we've got those set. We need to set the remote hosts IP. And that's going to be this fella, 315189. Port is already set as 445 for SMB. I think we've got everything we need to go ahead and run this sucker. We didn't set a payload. Alright, let's take a look. Set payload Windows x64 interpreter reverse TCP. Let's try running it again, see if we get anything new. Let's try. So it's saying bad username or authentication informations. SMB Pass Academy, and the problem is we've capitalized Academy. So now it should work. That's looking better. So now we have shell access here to our Windows machine. Just running some random commands to see what we get for a second. ipconfig interfaces, blah, 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 blah. Alright, so we want to dump the hashes right here from the SAM database. We should be able to use hashdump. There we go. So we've got the hashdump set. Let's go ahead and copy this. Let me copy. That didn't work. Alright, let's try this again. Copy selection. New tab. We're going to do an echo command. Echo. I bet we already have it. That looks fine. Echo. It's probably in documents if we have it, but let's go ahead and Control-Shift-V. And I put that in quotes to make it a string, and now I'm going to output it to. Why'd you do that? Oh, you're gonna do that junk to me today, eh? It all looks fine, but let's see if it works. It's linting oddly, which means the color isn't what it should be. It should be that orange string color. Windows 1 hash. File name too long, silly boy. Alright, let's try it again. It's just being a punk. Let's try maximizing the screen. Seems to help for some reason. Echo. Control-Shift-V. Close it. I don't know why it's doing that, adding extra crap to it, but we'll just delete it within the file once it's done. Windows 1 hashes output ls. I wonder if it worked the first time. No. rm Windows. rm is for remove. ls. So there we go. Now we'll go ahead and jump into, we'll try vim. Windows 1 hashes. And then that actually looks correct. It didn't seem to save the extra admin in it. So we'll go ahead and do Command Q to exit. That was :Q to exit vim. And sorry, I've got a webcam set up differently today because my laptop bricked. So I've got my phone as the webcam. It's kind of covering the bottom left of the screen. So that's why I'm peeking around a little bit. Let's go ahead. Oh, hey, Monster Hunter. Let's go ahead and we've got the hash. In Windows hashes, now we can go ahead and cat that. Cat, cat. Cat, 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 cat. What you talking about, bruh? Oh, because I'm a dum-dum. Cat. Now let's go ahead and copy the hash for administrator 2. Try that one. The hash is this and this, NT hash and then LM hash, if I remember correctly. The colon stays. You we grab the stuff on either side. Copy selection. We're going to grab the hash for the administrator 2. And now we are going to go ahead and get back to our interpreter session. We're going to put this guy in the background, our current session. And now we're going to establish a session in admin 2, or in the second Windows system with the admin 2. We're assuming that the admin has lateral privileges across different systems. So let's go ahead and find our other Windows system here. So 315.7.221. I'll just load it up to verify on this side. We wouldn't obviously have this capability in the real world hacker situation, but that's the beauty of training. All right. Sorry about the mouth noises. This mic's a bit more sensitive. IP config 315.7.221, 315.7.221. What a beaut. All right. So now we are going to see what the options are. We don't have anything. We do have the old stuff set, so we'll go ahead and set SMB pass to our, let's try Control-Shift-V, to the hash. And this is called passing the hash. SMB, this exploit should take the hash as the password. We'll set the SMB user to administrator 2. Spelling looks correct. Set our hosts to the new IP 315.7.221. 315.7.221. All right, let's show options again just to see if we got everything correct here. We've got our pass, we've got our administrator 2, we've got our new IP. So we should be able to run this. And now we should have access to 2 different Windows systems, meaning we have successfully moved laterally from Windows 1 to Windows 2 after hash dumping the data from Windows 1 from the SAM database with the interpreter hashdump command. We can go ahead and clear this, and I'll show you the sessions. Lit background. We'll put this in the background, then we'll clear it. Then we'll show sessions, and here we go. Windows 1 session active, Windows 2 session active. If we wanted to get into Windows 1, interact argument, and then the number 1. Now we're in Windows 1, sessions, I2. Let's go background and try again. Blah, blah, blah. There we go. Okay. So we're basically in the 2, we've moved laterally. We have successfully moved from one Windows system to another. Learned a little bit about psexec. Learned how to figure out operating systems with nmap with the -O command. And grabbing the network range with IPA and seeing it right here. That CIDR notation is telling us what the network size is. To explain that quickly, each of these sections is called an octet because in binary they each have 8 bits. If you add 8, 8, 8, and 8, that's 8 times 4, which is 32. Each of the sections, if we break them out into bits, we'd have 20 out of 32 reserved for the network range, and then the host range is the remaining 32 minus 20 is 12. So the last 12 digits here, that would be this full section, and the last half of this would be the network range of this network that these systems are connected to. So look that up on YouTube. You can look it up like written on paper, Saturn notation explained simply or something like that. And you'll see someone just drawing out a bunch of ones and adding the ones together, and it'll make more sense that way. Anyway, use responsibly, hack good, be a good person, learn real good. You know. Bye.